components, external and internal information, strategy, customer requirements, customer complaints, and previous non-conformances. Safety team need to consider biological, chemical, and physical hazards. There will also be a need to consider allergens, which is quite common, and sometimes radiological hazards. Associated with raw materials from which the products are made, or may be introduced during the process by people, the environment, or the process itself. Naturally occurring chemical hazards include customer requirements, customer complaints, and previous conformances. The safety team need to consider biological, chemical, and physical hazards. There will also be a need to consider allergens, which is quite common, and sometimes radiological hazards. Biological hazards can be associated with raw materials from which the products are made, or may be introduced during the process by people, the environment, or the process itself. Naturally occurring chemical hazards include aflatoxins, mycotoxins, and shellfish toxins. Added chemical hazards are those which are usually unintentionally added to ingredients or food. Foreign materials such as glass, metal, or plastic are typical physical hazards in products through lack of control while the food was being produced. Any possible hazards. Your food safety team should be aware of those relevant to your products and processes. The first step in identifying hazards which might be associated with your process might be considered a brainstorming session. The hazard team consider all of the hazard that may be reasonably expected to occur at each step from primary production, processing, manufacture, and distribution until the point of consumption. Identify which hazards of such a nature their elimination or reduction to acceptable levels is essential to produce a safe food. In conducting the hazard analysis, wherever possible, the following should be included: the probability of the hazard occurring, the severity of the adverse health effects, the qualitative and/or quantitative evaluation of the presence of the hazards, survival or multiplication of microorganisms of concern, production or persistence in foods of toxins, chemicals, or physical agents, conditions leading to the above. So ISO 22000 clause 8.5.2.2.2. The organisation shall identify steps each food safety hazard can be present, be introduced, increase, or persist. When identifying hazard, the organisation shall consider the stages preceding and following in the food chain, all the steps in the flow diagram, the process equipment, utilities, services, process environment, and persons. For each food safety hazard identified, the acceptable level of the hazard in the end product is determined, justified, and recorded, taking into account regulatory and statutory requirements, customer food safety requirements, historic information, scientific literature, professional experience, intended use of the end products, and other relevant information. Hazard list is referred to as a preliminary hazard list and covers all the hazards that could potentially occur in the product. Hazard assessment. Each potential food safety hazard should be risk assessed to determine whether its elimination or reduction to acceptable levels is required to produce a safe product, and also any controls required to achieve the acceptable levels. For each step, grades of impact are the severity of the adverse health effects in relation to the intended use, and the probability, the likelihood of its occurrence in the end product prior to application of control measures, are allotted, and the combined matrix used to judge the significance and priority for elimination and minimization of the hazard. So, food safety team assesses the likelihood of the hazard occurring. Then the food safety team assesses the severity of the hazard. The food safety team determine all the significant food safety hazards. In this example, the food safety hazards that score a 9 are regarded as significant and form the significant food safety hazard list. 8.5.2.4 Selection and categorization of control measures. So, the hazard team must then consider what control measures, if any, exist which can be applied for each hazard. More than one control measure may be required to control a specific hazard, and more than one hazard can be controlled by a specific control measure. The hazard team should select an appropriate control measure or combination of control measures that will be capable of preventing or reducing the identified significant food safety hazards to defined acceptable levels. So, for significant hazards, decide what control measures are in place for the hazard. When developing your hazards analysis, it's important to keep supporting documents such as regulations, scientific papers, studies, in-plant studies, and historical information about the process for the decisions reached by the team. So, selection and categorization. The systematic approach, the food safety team should categorize selected identified control measures to be managed as PRPs or at CCPs. For each of the control measures selected, there needs to be an assessment of the likelihood of failure of its functioning, the severity of the consequences in the case of failure of its functioning. For each of the control measures selected, there needs to be an assessment of the feasibility of establishing measurable critical limits and or measurable observable action criteria, feasibility of monitoring to detect any failure, and the feasibility of applying timely corrective actions in the case of failure. So, what is the likelihood of failure of its functioning? Consider if, never fails, slight risk, possible failure, likely failure, guaranteed failure. If not effective, modify or look for a different control measure. What is the severity of the consequences in case of failure? Consider, would a failure mean very severe, life-threatening event to a minor non-mobilizing injury not requiring treatment? Consider what is the effect on the identified significant food safety hazard. Eliminates it. Significant reduction, some reduction, little effect. Consider what is the location in relation to other control measures. At the end of the process, near the end, mid-process, start of the process. Control measures specifically established to reduce the hazards to an acceptable level. Is a control measure a single measure or is part of a combination? What is the feasibility of establishing measurable critical limits and or measurable action criteria? What is the feasibility of monitoring to detect any failure to remain within the critical limit and/or measurable, observable action criteria? So, can be monitored to detect any failure 100% of the time. 2. Very little monitoring. What is the feasibility of applying timely corrections in the case of failure? For each, consider if the control measure is likely to be a CCP, OPRP, PRP, or not effective. Non-effective control measures should be modified, or you should look to choose a different control measure. It's good practice to make notes of your findings of the assessment of control measures. So, I prefer to use the traditional codex decision tree to confirm critical control points. There's no requirement for this. An alternative was provided in guidance but withdrawn. As long as your method is logical and the decision-making process is documented, that's fine. So, are control measures in place for the hazard? Does the step eliminate or reduce the hazard to an acceptable level? Could contamination occur at unacceptable levels or increase to unacceptable levels? Will a subsequent step eliminate or reduce the hazard to an acceptable level? So by doing that, I confirm CCPs. But the food safety team also need to validate that control measures and combination of control measures included in the hazard control plan are capable of achieving the intended level of control of the food safety hazards. When validation results fail to confirm the above, then the control measures are re-evaluated and appropriately modified or changed by the food safety team. So confirm your decisions if control measures are to be implemented as CCPs or OPRPs or PRPs. So, safety team have now decided if control measures are part of operational prerequisite programs or CCPs in the hazard control plan. Significant hazards that are not CCPs should be controlled by operational prerequisite programs. Other hazards identified in the preliminary hazard list should be controlled by prerequisite programs. So on to a hazard control plan. Again, this is new in 2018. The hazard control plan, HACCP/OPRP plan. The hazard control plan needs to include safety hazards to be controlled at the CCP or OPRP, critical limits at CCPs or action criteria OPRPs, monitoring procedures, corrections to be made if critical limits or action criteria are not met, responsibilities and authorities, records of monitoring. Action criterion is established to determine whether an OPRP remains in control and distinguishes between what is acceptable and unacceptable. Many control measures are commonly applied in food processing. Not every process is the same, and that is why it's so important to use your own hazard analysis. Some of these may be CCPs or OPRPs. From the withdrawn guidance 22,004, you should considering the impact of a control measure on the hazard level or frequency of occurrence. The higher the impact there is, the more likely a control measure is a CCP. Considering the severity on consumer health of hazard that the measure is selected to control, the more severe it is, the more likely it is to be a CCP. The more need for monitoring, the more likely a CCP. The more precise limits, the more likely a CCP. So critical limits are exact and specific limits required for food safety using the preventive measures put in place at CCPs. ISO 22000 requires, as well as critical limits at CCPs, action criteria for operational prerequisite programs need to be specified. The rationale for their determination should be maintained as documented information. Action criteria for OPRP shall be measurable or observable. I just mentioned validation again, as action criteria and critical limits need to be justified, validated, and documented. Validation must be completed prior to implementation and combinations of control measures to be included in the hazard control plan. Supporting validation document can consist of information from, as we've mentioned, regulatory authorities, scientific journals, documented challenge studies. Monitoring systems at CCPs and OPRPs. At each CCP, the monitoring method and frequency shall be capable of the timely detection of any failure to remain within the critical limit, to allow timely isolation and evaluation of product. For each OPRP, the monitoring method and frequency shall be proportionate to the likelihood of failure and the severity of the consequences. When monitoring of an OPRP is based on subjective data from observations, such as visual inspection, the method shall be supported by instructions or specifications. Monitoring should ideally provide information in time to make adjustments to ensure control of the process. 8.5.4.4 Actions when critical limits or action criteria are not met. The organisation shall specify corrections and corrective actions to be taken when critical limits or action criteria are not met. Eight 5.4.5 is implementation of the hazard control plan. The plan should include process step, hazard, control measure, action criteria and critical limits, monitoring procedures, corrective actions, corrections, responsibility, and relevant records. This is an example of a hazard control procedure. Pasteurization. Critical limits are in red. Again, hazard control record, you can see action criteria and critical limits are in red. Updating of the information specifying PRPs and the hazard control plan. The establishment of the hazard control plan, the organisation shall update the following information as necessary, including characteristics, intended use, flow diagrams, and descriptions. Point 7 covers control of monitoring and measuring. The organisation should provide evidence specifying monitoring and measuring methods and equipment in use are adequate. Verification activities shall confirm that PRPs are implemented and effective. A hazard plan is implemented and effective. Hazard levels are within identified acceptable levels. And also analysis of results of verification activities. The food safety team need to conduct an analysis of the results of verification and that should be used as input to the performance evaluation of the food safety management system. 8.9 covers control of product and process non-conformities, including corrections, corrective actions, and the handling of potentially unsafe products. This section also includes withdrawal or recall, requirements for notifying relevant parties, handling withdrawn or recalled products, and requirements for performing the sequence of actions to be taken. And also to verify the implementation and effectiveness of the system through something like a withdrawal or recall test. Section 9 is performance evaluation. There's a greater emphasis on specifying monitoring, measurement, analysis, and evaluation. You need to specify what needs to be monitored and measured, the methods, when, and who. And there should also be analysis and evaluation. Organizations shall analyze and evaluate appropriate data and information arising from monitoring and measurement, including the results of verification activities, internal audits, and external audits. 9.2 covers internal audit. .3 management review. And section 10 covers improvement. There's a new section, non-conformity and corrective action, which is a general one. I'm just going to mention FSC 22000 additional requirements. The certification scheme was developed to facilitate broader acceptance of ISO 22000 and recognition by GFSI. FSSC 22000 is based on existing international standards. The scheme is intended for audit, certification and registration of organisation for a wide range of food chain categories. Requirements for FSC 22000 consist of ISO 22000. The scheme specifies mandatory application of technical specifications, as we've already covered. And then there's additional requirements in Part 2, which include requirements when external laboratory analysis services are used, requirements to ensure finished products are labelled according to applicable food safety, statutory and regulatory requirements, requirement for a threat assessment, for a food defence plan, for a vulnerability assessment, food fraud mitigation plan, logo use, requirement for a documented allergen management system, requirement for a risk-based environmental monitoring program, requirements for formulation of products for animal feed and transport and delivery for retail and wholesale. So we'll go on to questions shortly. Just want to say that IFSQM's obviously got an ISO 22000 implementation package. Many of the examples you've seen in this presentation includes food safety management system, procedures, records, prerequisite programs manual, HACCP manual, laboratory manual, training presentations, checklists, an implementation workbook, a startup guide, and technical support. So, any questions?
Дауысыңыз естілмейді ме, Серікна?